Hess's law of constant heat summation. This is today's lesson. Let us see the matter in detail. Hess's law of constant heat summation, which is simply known as Hess's law. Who is Hess? Russian scientist. G.H. Hess put forward this law in the year 1840. In this lesson, we are going to learn what is Hess's law and example of Hess's law. Suppose A is reactant and C is product. C is final product. That is, A is converted to C directly. C is produced from A in one step, and here suppose heat change is X kilojoule. Delta H1 is X kilojoule, and here C is produced from A in one step. Again, first of all, A is converted to B, and then B is converted to C. Here, from A to B, suppose here heat change is delta H2, which is Y kilojoule. Again, from B to C, here heat change is delta H3, Z kilojoule. This is obtained that delta H1 will be equal to delta H2 plus delta H3. That is, X kilojoule will be equal to sum of Y kilojoule and Z kilojoule, which is actually Hess's law. Hess's law is heat change will remain always constant whether the reaction is conducted in one step or in more than one step. That is, heat change doesn't depend on the steps of the reaction. Rather, heat change depends on the reactant and final product. When reactant and final product are same, then heat change will remain always constant. It doesn't depend on the steps of the reaction. Rather, it depends on the reactant and final product. This is Hess's law of constant heat summation. A is reactant and C is final product. This can be showed simply in this way. A is converted to C directly. Here, heat change is suppose delta H1. Again, another way, A is converted to B first, and here heat change is delta H2, and B again is converted to final product. Here delta H is 3. Then, according to Hess's law of constant heat summation, we can write delta H1 is equal to delta H2 plus delta H3. This is Hess's law of constant heat summation. Let us see one example. Reactants, carbon and oxygen gas, and product is carbon dioxide gas. Here, when carbon is burnt with sufficient amount of oxygen, then carbon dioxide gas is formed. And here heat change is minus 393.5 kilojoule. That is, carbon is converted to carbon dioxide with sufficient amount of oxygen in a single step. And here delta H is minus 393.5 kilojoule. Again, when carbon is burnt with oxygen, but here little amount of oxygen, then carbon monoxide gas is formed. Here half moles oxygen. In this case, delta H2, suppose this is delta H1. Delta H2 is minus 110.5 kilojoule. That is, here carbon is converted to first carbon monoxide gas, and in the second step, this is step number 1, this is step number 2. Carbon monoxide gas again is burnt with little amount of oxygen, half moles oxygen. Then carbon monoxide changes to final product, carbon dioxide gas. In this step, heat change delta H3 is minus 283 kilojoule. That is, here carbon dioxide is produced in 2 steps. In step 1, carbon monoxide gas is produced, and in step 2, carbon monoxide changes to carbon dioxide. According to Hess's law, we can write delta H1 is equal to delta H2 plus delta H3. Delta H1 minus 393.5 kilojoule, delta H2 minus 110.5 kilojoule plus delta H3, which is minus 283 kilojoule. That is, here minus 393.5 kilojoule. That is, heat change remains same whether the reaction is conducted in one step or in more than one step. That is, Hess's law states that if the reactant and final product are same, then heat change will remain same whether the reaction is conducted in one step or in more than one step. That is, heat change doesn't depend on the steps of the reaction, rather it depends reactant and final product. Hess's law of constant heat summation. These reactions can be showed simply in this way: carbon and oxygen reactants. In one step, reactants convert to carbon dioxide gas. Here, heat change is minus 393.5 kilojoule. But when carbon dioxide is produced in 2 steps, in the first step, carbon monoxide gas is produced. Here, heat change is minus 110.5 kilojoule, and then carbon monoxide gas is converted to carbon dioxide gas. In this case, heat change is minus 283 kilojoule, that is minus 393.5 kilojoule. Here, this heat change plus this heat change, that will be minus 393.5 kilojoule, which supports Hess's law of constant heat summation. Thanks for watching.